and I'm going to talk a little bit here today about data-driven insights on driver behavior in the age of automation. By and large, if anybody's looked at my bio, I work at the intersection of human behavior, technology, and public policy. I sit, or have recently sat in an advisory panel to the Secretary of Transportation here in the US prior to the administration change. I sit on an advisory panel for the FAA. I also do work in Europe and an advisor to AI Sweden, and sit on an advisory position for Autoliv, the world's largest safety supplier. So lots of different pieces and lots of different directions on have been working in the area of driver behavior, human factors, and growing for about 2.5 decades. So I think it's first to start, we talk about automated vehicles as they're new. And by and large, the history of driverless vehicles is really getting close to being a century old. So in the US, you can do a quick Google search and find the first experiment with remote control being coined driverless back in 1926. In the 1950s, GM invested copiously in the topic of automation. Autopilot was a marketing term used during the 1956 World Fair. It is not Elon's in the car sense. And it looks awful like Autopilot does today. 1980s, there were several prototype concepts, but it was really the 2000s and the DARPA Urban Challenges here that really stimulated the modern space race to autonomy. Google, based upon the output of that program, launched a self-driving car program, now Waymo. In the 15 or more years since, hundreds of billions of dollars investing in these areas. Lots of companies have been formed, lots of companies have disappeared. Lots of advanced driver assistance systems been involved through the development of new sensing compute capabilities for automation. But I think it's important, while things are a lot different and things are coming and growing and changing and all that, this quest to automate the driver out of the vehicle in various ways is nearly a century old. To me, using Malcolm Gladwell's words, the tipping point in automation in the car has absolutely nothing to do with Waymo, level 2 plus, level 3. It actually is the simplicity of the movement from the manual transmission to the automatic transmission that allowed us to pick up the phone and do other things. In essence, we automated the aspects of shifting to free up workload for other things. Power steering, stability control are all automation in different ways. Even the concept of backup cameras are sensing and display, changing the workload requirements and our behaviors as humans. Some ways, phenomenally good, making mobility easier for those less able. In other ways, bad. We're less engaged because we can be. Automation is relieving workload. Okay, so we were very much on a ship that set sail decades ago. We are just trying to deploy more and more automation, and often not asking the question, where should we be automating and where should we not? When we think about the cockpits, whether it's Boeing or Airbus, a lot of thoughts within the aviation community of talking about what makes sense to automate and what makes sense for the pilot to maintain engagement. In automotive, we say, let's automate because we can, as opposed to let's automate where we should. And that's the big questions we should be thinking about here. And I don't have answers. There are no real answers to this. There is a lot of value to convenience. Safety is important, but at the end of the day, cost of vehicles is out of control. So the cost of mobility is going through the roof. So hard part when we talk about autonomy and we talk across domains, across oceans, from the east to the west, autonomy really means different things to different people. And we often talk by each other, So when it comes to automated vehicles, autonomous vehicles, if you want to call it that, I don't like it. I like highly automated. Technologists, automakers, politicians really see the world through different lenses. Okay, the technologists that I know when we talk about highly automated vehicles are often not even thinking about the Waymo side. A lot of them are thinking about level 3. That's a step beyond what we're producing in product. Politicians are thinking about robots that roam the roads and move cars out of the sense of where they are today to something that's shared and more ubiquitous. Depending on which automaker, GM for a while was thinking level 4 is autonomy. through their cruise operation. Now, no, it isn't. It's Super Cruise again. So, as I wrote about in my Forbes blog, a couple too many moons ago, to some, vehicles and vehicle systems that encompass aspects of hands-free driving. To others, autonomous mobility on demand that serves as a neighborhood or a city. To the Brits right now, a mobility ecosystem that provides seamless intermodal connectivity. We don't want people taking automated taxis when they should be on the tube. And others, it's all about safety. And then there is no real common definition, and that's one of the things that makes it really hard to work behaviorally across technologies and policy. And the same really comes to AI. So we can think about automation as really a subset of AI, and I'll talk about that a little more in a few moments. So when we talk about autonomy, and we talk about automation, specifically in the form of advanced driver assistance systems or automated driving systems, we as engineers build these systems based upon engineering criteria. We have to put boxes around the ODDs of how we build things, and those boxes are often different than how humans operate the systems. So, we can call them for a moment conditional operating characteristics, i.e. the ADAS system's not expected to work in the snow. My car always tells me it's snowing out, the sensor's covered. What am I supposed to do? Not surprisingly, engineers haven't made the cost decision to heat the sensor to melt the snow off the radar. But by and large, drivers often have a lack of understanding and skills necessary to leverage the technology. Should it work now? Should it not work now? Where's the reliability? What should I do? Some of it's transparently provided, some isn't. Many systems require management and oversight in ways that humans aren't really capable of. We don't oversee highly automated technology well. Just look to 3 Mile Island and a number of aviation disasters globally. When the technologists build systems, they often assume they're going to perform ideally and the human is going to be there when it needs to be. Unfortunately, we get distracted, tired, and our attention diverges otherwise. And finally, infrastructure is far less than ideal, whether that's the road lines that aren't being paid frequently enough or retroreflective enough, or it's the fact that there's potholes and craters in the US infrastructure or many of the third worlds that high automation is not really great for. So it's not saying past research is wrong, it's just limited in scope and context when it comes to understanding how actual customers on real roads use these technologies that in the lab work beautifully. It's also why the insurance industry globally projects benefits of these technologies based upon all the assumptions that they understand early on, but these assumptions rarely equal real-world benefits when the crash and claims data comes in. In essence, we need to develop a deeper understanding why our projections are not as effective as they need to be and integrate that earlier in the design side. So if the answer is really heating the sensors so that AEB works more effectively in the snow, because that's where the crash and claims are, or the fact of the matter is we have to factor in, if you're driving in northern climates, these are how effective these technologies are. We need to complete the data circle here. So about a decade ago, I founded and now co-lead the Advanced Vehicle Technologies Consortium at MIT, a partnership between about 30 different stakeholders and academia to collect and analyze data that helps us objectively categorize some of the behavioral and safety benefits of advanced driver assistance systems, higher levels of automation, and real use conditions. Auto manufacturers, suppliers know a ton about each system they are developing. But once those systems are put into the hands of the consumer, most of them, not all of them, Tesla's a unique case, don't know much about the use and misuse of those systems. Why are drivers choosing to use them? Where are they choosing to use them? How are they performing? And more importantly, one manufacturer often has very little data around how different manufacturers' design philosophies are playing out in the real world. Each design team is making decisions that they believe are in the best interest of their customers. And perhaps it's a little of attributes from design 1 and a little of attributes from design 2 and so forth that are really the drink of choice that will probably be the answer long term. We see global regulators or NGOs like your NCAP making proactive decisions on it should be this way, but in reality, most of the data to really drive what innovation is, we don't have. So we are making decisions on technology development well in advance of, and curtailing designs well in advance of understanding how they're being used effectively. So continual process improvement is often short-circuited by early design decisions or or point systems through NCAP and so forth. Now, we are making some good educated guesses, but once we set something in a design standard of some sort, it's often really difficult to move back from that. So, the concept of continual process improvement that exists in many other industries, does not exist effectively enough with automotive vehicle technology. So to date, we've spent lots of time with a bunch of different vehicles. We started our work early with Land Rover Evoques, moved on to the Volvos with Pilot Assist, first conservative level 2 system introduced in the US. Moved on to the Cadillac CT6 with Super Cruise, Tesla vehicles, a variety of different shapes in Ford, the Ford Mach-E, and are working on acquiring some BMWs with their new level 2 system. The consortia maintains one of, if not the largest academic third-party naturalistic driving data set involving vehicles with partial automation features. We have probably north of 1 million miles of naturalistic data, with at least a quarter of that with L2 engaged. Tens of thousands of transitions of control. The data set continues to grow by the day. We're using this for a variety of different things. Looking at as close to we can as apples to apples comparisons between different production systems. How do behaviors look between Super Cruise and Pilot Assist, or Super Cruise and Blue Cruise? How automation is reshaping behaviors. There's no expectation, much like automatic transmissions allowed me to pick up the phone a little easier, so level 2 systems allow us to do some things a little differently as well. The shift to kinematics in driving, whether that's based upon electrification or automation, we often looked at high G events in history. Those high G events are very different today with AEB. Consumer preferences, beginning to think more about the risk-benefit models of assisted driving. And this just gives a smattering of a few points of interest. To give you a flavor of what this all looks like, we have lots of telemetry data, but here are 4 quadrants of video. An individual here experiencing an AEB event in stop-and-go traffic in a construction zone. When you look at his eyes, which I can't display in a recording, you can see that perhaps just staring into blank space as the car's brake lights in front of him go red. And I'll play that one more time for you to see. Hopefully it comes through well enough. And nothing complex. At the end of the day, brake lights go on, driver keeps moving at relatively high speed, and the automation takes over to brake for them. Another illustration here, early illustration of autopilot in a Model S in a construction zone. Drivers sitting here using their knee to nudge the wheel a little bit, looking off the road for a considerable amount of time as they look to the back seat. Again, not surprisingly, the automation's handling it. Now, where is not tying on your list of non-driving related activities? So much time to kill in the vehicle that texting isn't the answer. Not tying is for this individual. Lots of time we like to think about adverse attentional behaviors with autopilot. Here's an individual with Pilot Assist, which has some significant hands-on the rail requirements in this version. Left hand is on the wheel, right hand is on the phone. First glance away from the road is about 13 seconds. The second one's about 12 seconds with a very brief check of what's in front of the vehicle, all while driving at nearly 60 miles an hour with a child buckled in the back seat. So in this case here, the driver drove for, on round numbers, 25 seconds, looking up for a fraction of a second. Otherwise firmly focused on one hand texting away. So it is not a autopilot related phenomenon. The fundamental underpinnings are highly consistent. Finally, here's an illustration of Super Cruise. Super Cruise is designed, developed, and marketed as a hands-free driving system. It has a driver support system that is world leading, but it is designed to allow someone to eat their cheeseburger. And it has with that a number of pluses and minuses. And again, very different in nature than other features that we often talk about more frequently. Blue Cruise has a lot of design characteristics that were built off of the Super Cruise base. The original version of Super Cruise was launched in a 2018 vehicle and was developed over the course of nearly a decade before that. So GM was very world leading in the development of this vehicle. It's the first use of coherent driver support really in production with level 2. And I say coherent because it is a very well designed system. The driver support system very integrated with the automation as opposed to an afterthought. So just a little data here. Come from MIT. There's got to be some data involved someplace. Some of the data that we begin to look at is, okay, where's autopilot used? How often is it used on the highway versus non-highway? It is used primarily as a highway feature. It's designed as a highway automation feature, so it's not really surprising. But if we begin to look at the reported statistics around autopilot safety, even from Tesla, the fact is highways are the most, and motorways are the most safest road classes. Well, you would accept the technology that is used in primarily safer conditions to perform exceedingly high on a safety bar. So when we think about autopilot crashes, if they're occurring on the highway, very few crashes actually do occur in the highway. So everything becomes very quickly outliers. On primary, secondary roads, we see a lot more crash types. We see that with pilot assist here in this example, some work with the Insurance Institute for Highway Safety, led by Ian Regan. When drivers are using automation for a period of time, over time, they begin to take their hands off the wheel more frequently, and they begin to disengage from the driving task, doing non-driving related activities more frequently. No mystery. We automated to make driving easier, and we as humans fill that with something. So, again, lots of people like to critique, well, distraction goes up with automation. Well, we're reducing workload. What else would you expect? People are not necessarily distracted in the same way, but they're engaged in other activities, whether that's mental thought or that's picking up the phone. We free resources. We as humans fill those resources. And perhaps it's resources we would have filled otherwise. So it's very difficult to determine what is the safety effect. I mean, if you were going to send the text anyway, it's very difficult to say, are you more likely to if the automation was there, or were you going to do it anyway? Because quite frankly, the automation is being used in traffic environments that are much simpler. So if we look at autopilot here in particular, you turn on autopilot, you see the purple circle here on the left side at time 0. When you're manually driving, going to autopilot. What do you do when you turn on autopilot? Well, we take our hands off the wheel with a probability of about 45%. Okay. Now, high control here represents 2 hands high on the wheel, medium control, 1 hand high on the wheel, low control, 1 hand low on the wheel, no control, no hands on wheel. Okay, so you turn automation on and you reduce your control of the steering wheel, no mystery, but you maintain that really through steady state autopilot use. It's not to the seconds prior to disengagement on the right autopilot to manual that your hands really go back to the wheel. Now, interestingly enough, very little of the time, drivers are actually engaged in what we teach them to do, 2 hands high in the wheel. Okay, so no mystery, we automate. What are people using it for? To take their hands off the wheel, whether it's designed as a hands-free system or not. What happens? Autopilot goes on. Driver attention to the road drops drastically for a brief second. Driver attention to the instrument cluster explodes. Is the automation on to support me? Did the icon go from gray to blue? So the interface with the Model 3 and X, or Model S and X, is designed in a way that actually people are visually checking. Did the automation go on to support me? Now, could haptics be used? Could a heads-up display be used? Lots of other things could be used. Could even a more salient change in the icon, help provide information so you don't see such an instrument cluster glance here. Few seconds, 3 to 4 after autopilot is turned on, where does the attention shift? Over to the center stack. Why? People are beginning, or down in the center stack, people are beginning to do other things. So one of the interesting facets here, and there's some citations to all this on the bottom right, a couple years old, the proportion of off-road glances exceeding 2 seconds was originally considered to be a long off-road glance. Okay? During autopilot use, 22% of the glances away from the road exceed what was conventionally defined as a long glance. away from the road. So, very much redefining what we once thought about as safety and how the human monitors the road to support safety. This compares to about 4% after disengagement. Some work out of Sweden with ACC and lane centering found about 8 to 11% in some other vehicles. So one thing that's really intriguing is the notion of transition between automation levels. And this illustration is in the Cadillac CT6 with Super Cruise. How people work between level 0, level 1, level 2 driving. And a vast majority of the research has been done around, okay, what does the driver do when the automation system says, hey, I can't handle this anymore? Okay, and in that point of a system-initiated transition of control, how does the driver handle that situation? Well, by and large, that is the rarity. The majority of the time, what drivers are doing is proactively managing the system. So proactively saying, hey, something's coming up and the system is reaching its ODD. I want to drive again right now for reasons that we don't have a neural plug to understand. But they're saying, I want to drive. So the vast majority of the transitions are really the driver being proactive. Okay? How do we encourage that more effectively? In various designs to some degree do and do not. Okay? So we see that, even with many of the newer systems, and you hear about this in the news, we don't have data on Tesla's full self-driving, but we see in the news that the system seems to be supporting fewer system-initiated transitions. The system-initiated transitions are going to continue to become more and more rare, as the automation characteristics increase. So yes, the foundation literature and needing to understand there is critical, but what's overlooked is that drivers are actually being more proactive than we would have initially expected. And the naturalistic data several years ago began to tell us that. So how do we encourage drivers to be more proactive in their management of the technology? So while I'm sharing with you data here on the CT6 that's been published, the real fun stuff for us becomes comparing and contrasting how transitions occur with Super Cruise, with autopilot to pilot assist and so forth. And much of that work remains internal and shared with the supporters. So I think one real interesting part that I'll call and highlight here is that, and I'll use Super Cruise as the illustration, but the fundamental behavior is highly consistent with other vehicles, is that when the automation does disengage, okay, and the automation says, hey, driver, it's your turn now, you don't have a choice, and that happens at the end of the ODD for Super Cruise or where lane lines disappear for autopilot and so forth. Driver attention to the road decreases instantaneously. Driver attention to the instrument cluster increases almost instantaneously. Okay, and this is true across vehicles. We, as information-seeking individuals, are looking to the vehicle at the moment when I need you to be most attentive for information to support why did the automation disengage. So in essence, at the moment where the system is making a decision, I can't handle this, and I need the driver to acquire situational information from the road to say, oh, I need to take over now. The driver's looking to the instrument cluster or the center stack in the Model 3 for information from the automation on what's wrong. So not, the behavior we're looking for is look first, then figure out why. No, it's figure out why first. Again, what's really interesting here, this is not a Super Cruise behavior. It's a behavior we see in multiple vehicle systems. It's published here related to Super Cruise. Moving beyond experimental data here, in Super Cruise, when it does initiate a system-initiated transition of control, we can look how fast their hands come back to the steering wheel. Lots of simulation data that's been developed here, but at the end of the day, the simulation data is only good. How do we build the simulation? We need to validate that to the real world so that we can actually experiment in the lab with data that is robust and valid in real world situations. So what do we see here? Starting prior to the transition, left of 0, no hands on the steering wheel about 75% of the time, one hand on the steering wheel just a little less than 25% of the time, and very rarely 2 hands on the steering wheel, again, fairly consistent with autopilot. The automation at time zero says, hey, driver, it's your turn. And Super Cruise doesn't completely disconnect. It maintains some functionality in there, and that's a topic for a different day. When both hands are on the wheel, drivers took control on average of about 0.6. It took on average of about, when both hands are off the wheel, drivers took an average of about 0.6 seconds, 33% longer to actively steer, as measured by the input, the steering bus of the vehicle. Okay, so we can begin to understand the costs of no hands versus one hand or two hands. Okay, and this data has been used by manufacturers and others globally now to hone the experimental work to hey, okay, how do we do better than this? But it's really important when we think about things like driving simulation. We love to do experimental work in the lab, but that data collected in the lab is only as good as the validity of the experiment itself. I did a ton of work early in my career around driving simulation. I can create a simulation to show you anything. The key is that valid? I've done a lot of work over the last 2 decades around the topic of driver monitoring and driver support systems. My doctoral work 25 years ago was around eye tracking in vehicles, the precursor to what we see today is DMS. For a variety of reasons, automation being one of them, driver attention really may be at historic lows. We are natively just distracted by our phones. As my family tells me, I am picking up my phone way too much. Automation may be exacerbating this, but we are just, isn't culture in the US, Europe, and other parts of the world just distracted to a large degree much more frequently. Driver monitoring, okay, the sensing side of where I may be looking or if I'm touching the wheel, plus driver support, what do I do about it, could potentially offer benefits under all automation levels, but we really don't know what these benefits are. We only see really driver support effectively being used with automation at the current time. In Super Cruise, Blue Cruise scenarios, we see very little data at this point on how it's working at a level 0. Automation needs to be coupled with increased comfort and convenience, environmental impacts, but also requires systems that help support drivers in their new role. Autopilot in particular has been criticized by me and many others for its lack of cohesive driver support. Helping drivers monitor, helping drivers collaborate with the automation, and ensuring drivers are ready for takeover. Okay, DMS may be critical to risk and liability management, but new approaches are needed to really move beyond the car itself, perhaps using incentives outside of the car or regulatory efforts in other ways, to begin to ensure we are providing drivers with the right support systems. Some of the early work we did on this is published in a IEEE pervasive computing piece on monitoring, managing, and motivating driver well-being. It's work that started in 2005 with the support of Toyota, Ford Motor Company. So we think to the future, we as humans are experiential learners in nature. We learn by doing. So we learned to drive from a little driver education early on, but a lot of driving. So today, the vehicle's miles traveled is relatively equals to the vehicle's miles driven. There are a few robo-taxis out there and lots of vehicles out there that are quote unquote doing most of the driving right now. Okay, and quite frankly, full self-driving and autopilot are two of them. So the driver is not necessarily navigating all the situations that they once did. In essence, we're traveling at times without fully driving the old-fashioned way. Tomorrow, vehicles miles traveled and quote unquote vehicles miles driven are going to continue to diverge more. And at some point, they're really going to be not equal. Okay, and I do believe that the automation is providing only a small fraction of the miles today globally. As they diverge, we are going to experientially learn less. So unless we change direction to some degree, we are talking about a future of relatively quote unquote novice drivers. Anybody who has studied novice drivers realize that they are a high-risk group. So no surprise, we are likely as a culture going to become a higher risk group without the support needed. So most of the automation designs right now ignore this fundamental theoretical component that is just needed. We need support. We need to learn by doing. And that's not necessarily by book education. That's physically with the steering wheel in hand. The FAA in the US admitted years ago that pilot skill was eroding at the expense of automation. The same will be true in cars. So transitioning directions a little bit, modern autonomous driving was really predicated on advancements in AI. And while AI is really cool and really complex, and the latest version of ChatGPT is, quite frankly, incredible, the path to highly automated driving is very long and very winding. Waymo still exists, trying to push the envelope forward. Cruise is now gone from and charted its role in the history books. Lots of organizations globally talking about lots of different development objectives, whether that's end-to-end learning or that's using more traditional machine learning, whether that's using more lidars, less lidars, lots of different technical directions here. There are some key commonalities. Operational domains are complex. There are limitations in sensing and compute beyond just the vision versus lidar this debate out there. We can't see information as proactively through sensors as humans can in ways. We have intuition that we have not capable of modeling through AI at this point. We have for long provided an overhype and aggressive growth plan to technologies that is still nascent and very well, only providing a limited amount of high cost trips. Perspectives on safety is tied to drivers. Human constituents globally are not going to be happy with automated vehicles harming as many people as humans do. Does it have to be a factor of 10 better, or a factor of 100, or a factor of 1,000 better? I don't know. The amount of back-end capital through teleoperation has been consistently underreported. There is a lot of human capital in teleoperation and other back-end design, development, testing, deployment applications that we do not discuss. Complexity involved in building and maintaining trust. Cruise's venture did not end with the fact that they were the secondary strike to a pedestrian. It ended with a lack of trust in the organization. And it's very possible that Waymo might suffer a similar fate if they are not as transparent as the airlines have known that they need to be to build our trust in getting onto airplanes. Big air carriers know that one accident is an impact on the entire aviation ecosystem. Boeing is a company today that has been suffered through a number of war rooms by lack of transparency. Airbus seems to have become a much more transparent company in the last decade or two. I think the biggest issue, however, though, is a challenge of moving from investment to a revenue-producing business. These are companies, and Waymo in particular, we hear about they raised $5 billion, but their budget is several billion a year. How much runway do they have, and how do they move from an investment model of burning enormous capital to one that actually produces revenue? And is that really feasible? And there's a lot of folks out there that say at this point, it's not feasible. In essence, great, we can automate technically, but it's not a business that can produce the revenue required. I, for one, think Waymo's expansion is all tied to, at this point, the need to produce more capital investment and less to do with the need for expansion. I think that smaller demonstrations on producing both the technical development as well as the business models are critical. Missy Cummings, a colleague, talked a bunch between the link between automated vehicles and AI and connecting what self-driving cars tell us about AI risks. I think her piece in IEEE Spectrum is a must read. 5 conclusions from experts. Human errors in operation get replaced by human errors in coding. AI failure modes are hard to predict. Probabilistic estimates do not approximate judgments under uncertainty. And maintaining AI is just important as creating it. Life cycle costs are incredibly important. I've talked about that in multiple places in recent years. And finally, AI systems have system level implications that just can't be ignored. That comes back to some of what we talked about earlier around trust. I think Missy's piece is a must read here in understanding how tied AV and AI is. So when we think forward around AI and automated vehicles, I think we need to be thinking much more coherently about balancing risks and reward. Edge cases will absolutely become rare, but may always exist, creating brittleness. AI and automation change the nature of work. We've known that through theoretical work for decades. and have that impact on workforce planning, and care will take that forward. But there's going to be a lot of people worried about how all highly automated vehicles change jobs for a long time. Misuse and overuse of technology, yeah, it requires guardrails. Liability will change, to hold model developers and users responsible differently. Right now, we blame the user who rear-ended the automated vehicle. The reality is the developer of that automated vehicle changed the model of driving that braked faster than a human was capable of, does have some shared responsibility. And that's a huge gap in some of the safety modeling around automated vehicles today. There is a lot more shared responsibility than traffic law was designed to manage. Society is not necessarily ready for systems without human oversight. But I'll argue that, at some point we will get there. It just might take the best part of a century. So to tie this all together a little bit, self-driving cars, fact or fiction? The reality is probably a little both. Higher automated vehicles, will continue to emerge as technology improves and business cases evolve. However, they will require human oversight and have limited impact on how we live and move for a long time. Yeah, Waymo's operating in a bunch of cities, but at the end of the day, it's a very, very, very small populace of the world. There's demonstrations in China, but again, impacting a very small number of people. Is this a year or two? No, it's probably a few decades out there until it hits more individuals globally and beyond the rounding error. And more importantly, there's aspects of the world we live in that it just doesn't make sense. It's snowing out today, and the idea of moving on a slippery surface is not something automation engineers are going to want to overcome anytime quickly. Assistive automation, level 2 systems and the like, are poised for explosive market growth and will make driving more comfortable, perhaps hands-free at times, while hopefully improving safety. That's a big question mark. And we as a society have to wrestle with, is increased comfort okay if it comes with no safety cost? Or do we have to have a safety improvement at the same time? And I don't think anybody socially has accepted that. It's a philosophical question. While we will move towards highly automated, partially electrified, and connected mobility, some form of manual driving, perhaps still with a steering wheel, gas pedal, and brake, is going to exist for generations to come. There are environments where electrification makes no sense, where automation and connectivity will never exist. Whether that's northern Alaska, northern Sweden, northern Norway, or the southern hemisphere in Antarctica, I don't know. But there are situations where automation and connectivity and electrification just are not going to exist, and driving will exist the quote unquote old-fashioned way for decades, if not ever. In conclusion, I think governments throughout the world have an important role. The most important aspect is an agreement on the benefits of automation and setting some stages on safety, working together between the public and private sector to set goals and objectives that make sense. The public sector can't tell the automakers or the tech designers, here's what you need to do. Quite frankly, a lot of times it's outside the realm of what we can do. The private sector can't go back to government and say, hey, here's why we know all the answers for society. That doesn't work either. Safety targets are life and death decisions that impact a range of costs from suppliers to manufacturers to insurance. Ultimately, these are borne by the consumer. Okay, we can improve safety to a higher magnitude as long as we slow cars down and we increase the cost of cars by God knows how much. Well, if we can't afford to move, is that answering the society's answers either? How do we find that right balance? Give an advertised promise, non-optimal development of enhanced safety, convenience systems are eroding trust in some models. They're also eroding trust in the future of automation. Full self-driving, quote unquote, the marketing slang, doesn't really exist. This also may be a missed opportunity to excite and delight customers while simultaneously managing the ongoing health crisis on our roads. Society needs a common pathway to safer, greener, and more economical transport with clear, collaboratively select and communicated goals. Automation, electrification are opportunities for growth to develop a better system. Government, as I mentioned, needs to take an active role with all parties willing to collaborate. No one knows the answers that we like to put on text. But the reality is that, we need to work together to understand what makes the most sense for society stepping forward and looking at more continual process improvement versus, standards that begin over the long haul to curtail development design. So what's safe enough today and green enough today will not be tomorrow. I think that's a great part to transition over to questions.